Hey there, Math 1, Miss Sam's here. We're going to go over analyzing residuals. So as we know we're about to figure out what a residual is. So plotting and analyzing residuals. So for any data set, of course, there's different lines of fit that can be created. And then from student to student, it kind of varies based on the information and how you estimated those scatter plots on a graph whenever you weren't given a table. So some of these lines of fit will fit the data better than others, and one way to determine that is by using what's called a residual. So a residual is a assigned vertical distance between data plot and the line of fit. After calculating the residuals, a residual plot can be drawn. And so at the very bottom, there's three examples of a residual plot, and that's just a graph of the points whose x-coordinates are the variables of the independent variable, and y-coordinates are the corresponding residuals. So looking at the distribution of the residuals, this can help you determine whether the line of best fit describes the data or how well it describes the data. So if we're looking at this very first one right here, we're noticing that the residuals around the x-axis is random and tight, so it's very close there to the x-axis, so the line fits the data very well. In this part right here, we notice that the distribution of the residuals about the x-axis is random but loose. So the line fits the data, but it's very weak. So yes, it's in there and it's random, but it's loose fitting. It's scattered, but it's loose fitting. So it does fit, but it's a weak model. And so this last one right here, the distribution of the residuals about the x-axis is not random. Like, it looks very, almost like, not, I can't say linear because it's not a straight line, but there is a pattern to the plots. So the line does not fit the data well there, okay? So we're going to really dive into, first of all, what is a residual? Because that was a bunch of words. Let's see what this looks like with putting some math to it. Okay, so here we have a table of information. Okay, now if you go into Desmos and you put the table in, which I'm going to pause the video so I can do very quickly. Okay, so the particular information here is in Desmos. I had already pressed the zoom sign there so it zooms into where my data is, but don't forget there's that little zoom button there. And I'm going to go ahead and type in the equation there to find our line of best fit. Don't forget to use the squiggly one, x, and then 2 plus b. Okay, so as you can see, we had r, that was called our correlation coefficient, m is our slope, b is our intercept. So as you can see, I got the line 0.23, and then my y-intercept is 9.2. And then right here, it's called the residuals. Okay, so if it's already plotted. Okay, so here are my residuals based on, now this is very, very, very important, okay? This data right here, the residuals, is based on this particular equation using this slope and this y-intercept. Now, for your practice today, they're going to give you a line of best fit. Sometimes on the EOG, it's going to ask you to find the line of best fit and then plot the residuals, okay? But I just want you to know that, like, whenever you put this in the calculator, like, don't use this information in the table because they're going to give you a line of best fit to use. That's not usually, sometimes, I mean, it can be what the calculator gives you, but it could also be different. Okay, anyways, I talked too much. So we are going to turn this particular spot on, and then I'm going to hit the zoom button so I can see the residuals, okay? So down here, or I can also zoom in and zoom out with the two fingers there, like on the trackpad. Okay, so as you can see, like, this particular data here is very, very close to that x-axis. It's also very, it's close and it's tight to the x-axis. So we're going to go over here, and as you can see, the line that they're using right there says 0.25 plus 29. Okay, the line that the calculator told us was 0.23, and the y-intercept that was used was 29.2. So we are not going to use the residuals, okay, that the calculator gave us. I just wanted you to know that that's where it was. The question is asking you to find the line of best fit and the residuals. Okay, so let's dive into this because we're given actual. So to find the residual, we have to take the predicted and the predicted is based on the line of best fit there that they give you subtracted from the actual. So we need our predicted value. So what I'm going to do is I'm going to take 0.25, I'm going to multiply it by 29.2, and then I'm going to add 29. So basically I'm inputting, no I'm not, because that was my y value. Back up. I need to make sure that I'm putting in my x values into my line of best fit equation there that was given. So for example, I would use 0.25. So 0.25, because that was the slope that was given in the equation that was given to us. My x values, I'm really sorry, was like right here in this column. My x values are 0, and my y-intercept is 29. I don't know what is going on. We can be like trackpad here with this pencil, but my handwriting is terrible today. Okay, so the next one is 0.25. We're going to multiply that by 10, and then we're going to add 29. And then we're going to do 0.25 multiplied by 20, and then add 29. Okay, so I'm going to pause my recording so I can calculate these, and then I'm going to hit play whenever we're ready. Okay, so in this, I was able to calculate. So I put in my x value, and then I was able to calculate the y to get the predicted based on that line of best fit there that was given. So in this part over here in this column, we need to subtract the predicted from the actual. So we're going to do actual minus predicted. So 29.2 minus 29 is 0.2. 31.3 minus 31.5, 34 minus 34, 36.5 minus 36.5, 38.2 minus 39. So go ahead and complete that particular column. Okay, so I went ahead and did my subtraction. So we have our residuals being 0.2, negative 0.2, 0, 0, and then negative 5. And then, of course, those can be plotted from our actual and then our residual. Okay, so if I was to plot these on a scatter plot based on the information given, I would use my x-axis, or my x values that were given, so it would be 0, and then the residual would be 0.2. Okay, this next one would be 10, and then negative 0.2. And then we would have 20, and 0, and then 30, and then 0, and then 40. And negative 0.5. Okay, so next we're going to take it a little step further, and we're going to look at something called, the residual squares. Okay, so I'm going to take exactly everything that I just did, and now I'm going to square those. Okay, so here I had my residuals. I just copied everything over from the table before, and then I went ahead and squared those. And remember, squaring is simply just taking that particular value and multiplying it by itself. So I went through and I took the square, and then don't forget that a negative times a negative does give us a positive, which is how I got all positive values. Okay, so then you could also have a plot where you plot the square of a residual square, your x value, and then this will be your y. X, and then this will be your y. Okay, so we're going to compare these with another one. And so this one is going to be using the same data, the x and the y actual, but we're going to be looking at a different equation. And we see that this particular person, whoever this was, in this example, got the y-intercept of 28.8 instead of 29. Okay, and remember, to get the y predicted, we're taking my x values. So I would be taking my x value here of 0 and replacing it in for x inside of my line of best fit that was given to me. Okay, so here are all of our predicted values based on our linear model here. And then next step is finding that residual. So let's remember that residual is taking my actual, subtracted from, and subtract the predicted. Okay, so now that we have our residuals, our next step is doing the square of residuals. So I'm going to take my residuals and I'm going to raise it to the second power, which just in a sense is multiplying that number by itself. So you do 0.4 times 0.4, 0 times 0, 0.2 times 0.2, and then negative 0.6 times 0.6. Okay, so now that we were able to find the square of residuals, the fun part comes into comparing them. And so to compare them, you have to find the sum of those squared residuals for each line of best fit. And then whichever one that has the smaller sum of squared residuals is going to be the better fitting equation for that data set. Okay, so I'm going to go back to our very first example where all the writing hopefully is still there. And we need to find the sum of my squared residuals. And it was on this one. Okay, so I need to find the total of my squared residuals. So where I'm going to go is I'm going to go into Desmos. I'm going to add all of these up. Okay, so with that particular square of sum residuals, I got 0.33. So I'm going to go in here, and that was with my y-intercept being 29. And then next step is I'm going to go into my other line of best fit there that somebody gave us with being 28.8, and I need to add that particular square of residual sum. Okay, and that particular sum was 0.6 whenever I added all of those together. And so on my next slide, oops, that's not the button I need. There we go. On my next slide, I'm going to write 0.6. That was my sum of all of the squares, squared residuals. And then which line has the smaller sum of squares? That was one with the equation of y is equal to 0.25x plus 29. And then if it also helps, you can look at this as 0.60, or this is 0.33, or 60 100ths and 33 100ths. So this one right here is smaller. Okay, so as I just said, the one that has the smaller sum of squared residuals is going to be the better fitting equation or line of best fit for that particular scatter plot. So I hope this video has helped you, and as always, I am just a Google Classroom comment or an email away.